Good day, class. Today we'll be dealing with geometric sequence and geometric mean. Objectives for today are 1. Illustrate a geometric sequence. 2. Differentiate geometric sequence from an arithmetic sequence. 3. Determine geometric means and nth term of a geometric sequence. Okay, so to start, let's study this sequence. 5, 10, 20, 40, and 80. What have you observed? We can observe that we multiply 2 to get the succeeding term. 5 times 2 is 10. 10 times 2 is 20. 20 times 2 is 40. And 40 times 2 is 80. Let's move on with the next one. What have you observed? We can say that we multiply 3 to get the next terms. 1 times 3 is 3. 3 times 3 is 9. 9 times 3 is 27. And 27 times 3 is 81. Next. What have you observed? We can say that we multiply 2 to get the succeeding terms. 1 over 8 times 2 is 2 over 8 or 1/4. 1/4 times 2 is 2 over 4 or 1/2. 1/2 times 2 is 2 over 2 or 1. And 1 times 2 is 2. Let's have this last one. What have you observed? Okay, so to get the succeeding terms, we multiply the preceding term by 1/2. 200 multiplied by 1/2 is 100. 100 multiplied by 1/2 is 50. 50 multiplied by 1/2 is 25. And 25 multiplied by 1/2 is 25 over 2. Okay, so those are examples of a geometric sequence. What then is a geometric sequence? Geometric sequence is also known as geometric progression. It's a set of terms in which each term after the first term is obtained by multiplying by same fixed number called the common ratio. In the formula of geometric sequence, it is commonly denoted by or represented by letter R. Let's have this activity in your learning task 2. Determine the common ratio and the next 3 terms of the following geometric sequence. Okay, so the first row, the given is 4, 8, and 16. How does it become 2? So to get the common ratio, remember this. You need to divide the second term by the first term. So 8 divided by 4 is 2. Or, to make it sure, multiply the third term by the second term. 16 divided by 8 is also 2. So the common ratio of this sequence or geometric sequence is 2. Now, how do we get the next 3 terms? Simply multiplying the third term by the common ratio, which is 2. 16 divided by 2 is 32. To get the next term, 32 multiplied by 2 is 64. To get again the next term, 64 multiplied by 2 is 128. Let's have one more. What is the common ratio in this geometric sequence? Okay, so if we're going to divide the second term, 324, by the first term, 972, we will have 1/3 or 1/3. Okay, so to get the succeeding term, multiply 108 by 1/3. That gives us 36. 36 multiplied by 1/3, that is 12. And 12 multiplied by 1/3, that is equal to 4. That's how you get the common ratio of a geometric sequence and the next 3 terms. Now, let's move on with the formula of a geometric sequence. The formula in solving for the nth term of a geometric sequence is a sub n is equals to a sub 1 times r raised to n minus 1, wherein a sub n is the nth term of the sequence, a sub 1, you already know this, that is the first term of the sequence, and r is the common ratio. Let's have an example. Find the 10th term of the geometric sequence 8, 24, and 72. Okay, first thing to do is to find the unknown. Let's find the a sub 1 or the first term. A sub 1 in this geometric sequence is the first term, which is 8. Second thing is the number of terms or n. In this case, the value of n is 10. And lastly, the common ratio or r. So to get the common ratio, we divide the second term by the first term. 24 divided by 8 is 3. So the common ratio is 3. Now that we have these 3 values, we can now solve for this question. Let's write the formula of geometric sequence. A sub n equals a sub 1 times r raised to n minus 1. Then afterwards, let's substitute the values. A sub n becomes a sub 10 equals the value of a sub 1 is 8 times the value of r, which is 3. Then again, the value of n is 10 minus 1. First thing to solve is the exponent, which is 10 minus 1, so that's 9. So we'll just copy a sub 10, 8 times 3, this time 10 minus 1 is 9. Okay, next thing to do is to simplify this exponential form. 3 raised to the 9th power is equal to 19,683. You can use your calculator. Times 8. Then afterwards, we multiply 8 by 19,683. We can have the 10th term of this geometric sequence as 157,464. So this is the 10th term. Find the 8th term of the geometric sequence -2, 6, -18. Okay, first thing to do is to find a sub 1. A sub 1 in the sequence is -2. the value of n is equal to 8. And the common ratio is 6 divided by negative 2, that is negative 3. Let's try to solve for the 8th term of this geometric sequence. A sub n equals a sub 1 times r raised to n minus 1. A sub n becomes a sub 8. A sub 1 is negative 2 multiply by common ratio, which is negative 3, then raised to 8 minus 1. Okay, so 8 minus 1 is 7. So copy a sub 8 negative 2 times negative 3 raised to 7. Simplify negative 3 raised to 7, that is equal to negative 2,187 multiply by negative 2. Then, negative 2 times negative 2,187 is equal to positive 4,374. So, the 8th term of this sequence, negative 2, 6, negative 18, is 4,374. Let's move on to geometric means. What is a geometric means? It is the terms between any two non-consecutive terms of a geometric sequence. These are the examples of geometric means. They are written in a red color. In number 1, the geometric mean is 10. It is between 5 and 20. In number 2, the geometric means are 3 and 9. They are between 1 and 27. And example number 3, the geometric means are 150 and 25. They are in between 200 and 25 over 2. Let's have an example in solving geometric means. Find two geometric means between 5 and 320. Okay, first thing to do here is to visualize the geometric sequence. Okay, so given the first term, which is 5, we'll be inserting two geometric mean. So 5 is a sub 1, this one is a sub 2, the other one is a sub 3, and a sub 4 will be equal to 320. So we'll be needing two geometric means in between 5 and 320. Okay, so if we know the common ratio, it is easy for us to supply the missing terms. So what are we going to do is to solve for the common ratio using the geometric sequence formula. Okay, recall natin. A sub n is equals to a sub 1 times r raised to n minus 1. Okay, so this time, we will be needing the value of a sub n. In this case, the value of a sub n is the last term, which is 320. Also, a sub 1, we all know that a sub 1 is 5. And last is the value of n, or the number of terms. So where do we get the value of n? We will count this representation. 1, 2, 3, 4. Okay, so that will be the value of the number of terms. Okay, so let's try to solve. A sub n will be equal to 320. A sub 1 will be equal to 5 times the value of r, which is the unknown, raised to n, which is 4 minus 1. Let's try to bring this down, as well as 5 times r, then we subtract 4 minus 1 is 3. Okay, next thing to do is to isolate this r. So to isolate this one, we divide both sides by the coefficient of r, which is 5. Okay, so this will be cancelled out. What remains is r squared. And we divide 320 by 5. That gives us 64. Okay, so we'll only be needing the value of r alone. But this represents 3 r's. Okay, so we need to extract the roots by getting the cube root of 64 and getting the cube root also of r cube. Okay. Simplifying, we'll just cancel this out. And this one, what remains on the right side will be r. And if we get the cube root of 64, that gives us 4. Okay, so meaning the common ratio of that sequence is equal to 4. Now that we have the value of the common ratio, we can supply the missing term. We'll just multiply the first term or the preceding term by 4 to get the second term. So if we multiply that, 5 times 4 is equals to 20. Then, to get the third term, we multiply 20 by the common ratio, which is 4, that is equals to 80. And 80 multiplied by 4 is equal to 320. So meaning, the two geometric means in between 5 and 320 are 20 and 80. Find three geometric means between 3 and 1,875. First thing to do is to represent the geometric sequence. So we write the first term as 3 and we will insert 3 geometric mean. So insert tayo ng tatlong blank and the last term will be 1,875. Okay. Next thing to do is to name this as A sub 1, A sub 2, A sub 3, A sub 4, and A sub 5. And let's try to identify the needed values. We will be needing A sub n, which is the last term of this geometric sequence, and that is 1,875. Next is the first term, which is 3. And the number of terms, we will count the representation. So 1, 2, 3, 4, 5. So 5 will be the value of n in this question. Okay, so let's try to solve for the common ratio. A sub n equals A sub 1 times r raised to n minus 1. Substituting the values, A sub n is 1,875. A sub 1 is 3. r is the unknown, raised to 5 minus 1. Okay, so solve first the exponential form. Copy 1,875 equals 3 times r. 5 minus 1 is 4. Isolate r, divide both sides by coefficient of r, which is 3. Cancel out. What remains on the right side is r raised to 4. Dividing 1,875 by 3 will give us 625. Then to get the value of r alone, let's extract the roots. So since it is raised to the 4th power, we will get the 4th root of 625 and the 4th root also of r raised to 4. So this will be cancelled out. What remains on the right side is r, and computing for the 4th root of 625, that is 5. Okay, so now that we have the value of r, we can supply the missing terms in this blank. So 3, which is the first term, times r, which is 5, that is 15. 15 times 5, that gives us 75. And 75 times 5, that is 375. And 375 times 5 is 1,875. So the three geometric means between 3 and 1,875 are 15, 75, and 375. Always remember that math is fun. Goodbye and keep safe always.